All right, next up here, first up, actually, we have a pizza here. It's in a 425-degree oven, and then they put it in the kitchen, which is 75 degrees, and they tell us the cooling rate for this. So this is going to be our K value. They were nice and gave it to us in this case. So we're going to use Newton's law of cooling here. So I'm first going to set up my function here for part A. So time time t equals the temperature of the surroundings. So that's the kitchen. Plus, and then the temperature of the object is 425 because it's been sitting in the oven. The temperature of the pizza has raised to 425, and then minus the temperature of the surroundings times e to the negative 0.035 times t. So even though k is positive 0.035, the formula says make it negative k, so I put negative in front. So then for part A, I'm just then going to plug in 2. And so then it'll look like this. You could simplify that to 350 if you want, or you can just leave it like that, either way. So 0.035 times 2. So this is just a calculator plug and chug now. I don't need to use logs on this one because my variable is not in the exponent, so I'll just do 75 plus. And I'll go ahead and just type that in as 350 times e to the power of negative 0.035 times 2. And if I do that, I get 401.34 degrees Fahrenheit. All right, so then next up, part B. So for this one, they like to eat it at 95 degrees. So obviously that 401 degrees we got at the last one is not going to work. So for this one, we're going to go back to our original function, and we're going to plug in 95 out front. I will switch this to 350 now. It's going to make it a lot easier. All right, so now in this case, my variable is in the exponent, so I'm going to have to use logs to solve it. So I'm first going to subtract 75 over to this side. So I get 20 equals 350 times e to the negative 0.035 t. And then I'm going to divide this by 350. And so then I get e to the negative 0.035 t equals 2 over 35. And so then I'll do ln of 2 over 35, switching this into log form with the base of e. And that will isolate my exponent over here as negative 0.035 times t. So then I'm just going to divide by negative 0.035. And I'll just type that in the calculator now. So ln of 2 over 35 divided by negative 0.035 would be 81.78 minutes. So yeah, they're going to have to wait a long time for that pizza. All right, next up here we got number 2. So I'll let you guys try this one. Very similar to the previous. All right, next up here we have another situation. The can of soda is taken out of 35. All right, and then it's placed in the room where it's 75. So this is going to be the temperature of the surroundings. We're taking it out of the cooler and putting it into the room, so that's going to be my surrounding. And then this is actually going to be the temperature of the object. Because it's been sitting in the cooler so long, it has taken on that temperature. Now, they did not tell me K here, so I'm going to have to figure that out. So I'm going to say T of T equals T sub S, which is 75, plus parentheses T sub 0 is 35 minus 75 to the power times e to the power of negative kt. And then I'm going to use this other point that they gave me, the 20, 53.5. So I'm going to plug that in for temp. I'm going to call this negative 40. So actually, why don't I just do it as minus 40 times e to the negative kt. This parentheses should always be negative if it's heating up, because we're kind of using Newton's law of cooling backwards, which is fine. So now I'm going to subtract the 75 over. I'm going to do that on the calculator. So we got 53.5 minus 75 is negative 21.5 equals negative 40 times e to the negative kt. And so now I'm going to divide that by negative 40. And so comes out to 0.5375 equals e to the negative kt. So now I'm going to switch it into log form, so it's going to be ln of 0.5375 equals negative kt. Oh, you know what? I forgot to plug in the 20 for time, so it should all say 20. So I'll go ahead and plug that in now. So this is times negative 20k. So I'm just going to divide that by negative 20. And I'll say k equals ln of 0.5375 divided by negative 20. And I'm just going to leave that as my k. And then I'm going to go over here, and now I will actually, now that I have my function here, I'll write it out. So t of t equals 75 minus 40 times e to the, and actually since this was a negative there on the 20, and I also have a negative in the formula, those are going to cancel out. So I'm just going to put ln of 0.5375 over positive 20 times t. And so next up, I will plug in 65 since that is our desired temperature. I'm definitely not allowed to combine the 75 and the negative 40 here since the negative 40 is attached to E. All right, over 20 times T. So now we have to solve this. So I'm going to subtract the 75. So negative 10 equals negative 40 times e to the ln of 0.5375 over 20 times t. And then I'm going to divide by negative 40. So 1 over 4 equals e to the ln of 0.5375 over 20t. Now I can switch it into log form, so I get ln of 1/4 equals ln 0.5375 over 20 times t. So that isolates the exponent for me, and then my last step here is going to be to multiply both sides by the reciprocal here, which is 20 over ln of 0.5375. So now I can type this in my calculator, 20 over ln 0.5375 times ln of 1 over 4. And if I do that, I get about t equals 44.66 minutes. All right, next up, number 4, very similar to number 3, so I'm going to let you guys try this one. All right, next up, number 5, we want to find the domain. And so for the question of domain here, we just have to take the inside of the log and set it greater than 0. All right, so there you go. So now I'm going to factor here. I'm going to go ahead and take out a negative, and I'm going to call that 6x squared plus 7x minus 3. And then I'm going to do an x box, so multiply to negative 18 and add to 7 would be 9 and negative 2. I do need the box here because I have 6x squared. I have negative 3, and then I have 9x and negative 2x. So this will be 3x minus 1, and then 2x plus 3. All right, now I know I'm going to have to use test points here or draw a graph. I think that I'm going to draw the graph here, but I know that this is going to be x equals 1/3, x equals negative 3 over 2. If you are going to use test points, you need to include this negative out front. It's going to kind of change everything along the way, so make sure all 3 of your zones are negative. The way I'm going to do it is I'm going to draw these here, and then I'm just going to visualize this graph. It is a negative parabola because we have that negative out front wherever you look, so it is going to be looking like that. And so that means the plus part is in the middle, so it'll be negative 3 over 2, comma 1/3. All right, next up here, we need to decide if these are exponential functions, and if so, write the function here. So what I'm looking for is a consistent pattern of multiplication. So you know what, I'll go ahead and do g of x actually because it's a little tougher. So the thing I see here is that we're missing some, but the one that I have here, that's plus 1, I see that what's happening is times 1/2. And so I think that this is a times 1/2 pattern, which would make it exponential. So if I made this point in the middle here, 3 comma 1/2, you could see it would follow that pattern of times 1/2. And then if I put this one in the middle as 1 comma 2, it would do the same thing. So I think then that that is what this is. And so when we have that pattern of multiplying 1/2, that is actually the base. And then I know that the y-intercept is always a, so I'm going to say y equals 4 times 1/2 to the power of x. All right, next up, number 7. I'll go ahead and I'll do part B here. It's probably the toughest one. So we're going to set this equal to x. I'm going to switch it to exponential form, so 9 to the x equals 1 over 27. I would then write these both as the power of 3, so this would be 3 squared to the x, and this would be 3 to the negative third. And so that means that 3 to the 2x equals 3 to the negative third, which means that 2x equals negative 3, because I can just drop those once they're the same. So x equals negative 3 over 2. All right, next up here, it asks how long would it take for a loan to triple if borrowed at 15% interest compounded continuously. So whenever it's compounded continuously, we use a pert. But r and t are in the exponent here. All right, so we know that this is a 15% interest rate, so that's that. And then I'll put the t right there. And then it says for a loan to triple, so I would put, we can really use any numbers we want as long as a is 3 times as much as p. I would use 1 and 3 though. And so then I can just scribble out the 1 since I'm really just dividing it over to the other side. But now I can switch it into log form, which is base e. So I put ln of 3 equals 0.15t. And then we'll just divide by 0.15 to both sides. So we get ln 3 divided by 0.15. So t equals 7.32 years.